Hello, 7th graders. Welcome to another pre-algebra video. During this week, we are going to work with powers of monomials. We will use some of the knowledge we acquired previously when we worked with the product of powers property and the quotient of powers property. Our objective during the week is to simplify expressions with integer exponents. The I can statement is I can use laws of exponents to find powers of monomials. Remember that a monomial, as we previously learned, is a term that might contain a number, a variable, or both, the product of a number and a variable. So the vocabulary terms that we need to own and understand are powers of a power property. This is a property that states that to find a power of a power, we must multiply the exponents. So this is sort of a formula or the algebraic expression of the power. There's an example here, and then there's this example that we are going to go through together. So we've got 6 to the fourth power raised to cubed. So this is the same as taking our base. In this case, we're talking about 6 to the fourth power and using it as a factor 3 times according to the exponent. So we write the expanded form, which is 6 to the fourth power times 6 to the fourth power times 6 to the fourth power. According to the product of powers property, whenever we have the same base, we must just copy the base and add the exponents. So that's what is shown here. And by doing so, we obtain our final answer, which is 6 to the 12th power. That's one way of doing it, but an easier way is applying the powers of a power property, which states that we can just copy the base whenever this is the same and simply multiply both exponents. So 4 times 3 is 12, and very shortly and easily we reach the exact same answer, 6 to the 12th power. Then we also have the power of a product property. This property states that to find a power of a product, we must find the power of each factor and multiply. So let's look at the example right here, which we have 4a squared to the third power. If we want to write the expanded form, then we must use our base as a factor as many times as the exponent indicates we must. So we write 5a squared times 5a squared times 4a squared times 4a squared times 4a squared. If we must apply the property, then we multiply each factor, or we find the power of each factor and multiply. So the first factor is 4. It must be multiplied 3 times because it's raised to the cube. So that's 4 times 4 times 4. We repeat the same for the variable and the exponent. A squared, we multiply it 3 times. So a squared times a squared times a squared. That means that we have 4 cubed times a squared to the third power. That's what's happening here. And to simplify these, we are going to find the values of 4 cubed, which is 4 times 4, 16, and 16 times 4 equals 64. And then to solve this other one, we can simply copy the base, a, and multiply both exponents. So 2 times 3 equals 6. So our answer is 64a to the 6th power.